Hi guys, welcome to another episode of ReliaCast. I have here with me today Kevin Raymond from Network Rail, and our topic today is asset management. So hi Kevin, welcome
hi,
to
Chris.
the channel.
Hi, good to be here.
Yeah, great. So you have to introduce yourself and a little background, who you are, where you're from. And
Yeah, sure. Okay, so I'm Kevin Raymond. I work for Network Rail, as Chris said, and I'm responsible for Network Rail's design for reliability process, which is where we've moved from when we give product acceptance to products to allow them to be used on the railway. Previously, we were checking, are they safe, are they legal, and now we've got more of an emphasis on, are they reliable as well.
how did you end up in specialising in asset management in the rail sector?
Yes.
So how did that end up?
Yeah, this is one of the great things about becoming a chartered engineer, isn't it? You have to tick various boxes and cover various things and move around a whole range of departments, which is great because it gives you an opportunity to find out what you like and what you don't like doing. So once I started working at Ford, one of my first jobs was being a process engineer on the part of the production line that put the doors, the lift gates and the hoods onto the bodies before they were painted. One of the key things was getting the doors positioned correctly, because when a customer goes up to a car, they like to see a nice even margin all the way around it. So it's all about getting it set up correctly. So lots of measurements being taken. And when I first got there were people that used to turn up in white lab coats and they'd take something away and measure it, or they'd go to the car and they'd measure things up and so on, and then they'd go away and they'd analyse it. But one of the things that I did was I got the people that were involved on the production line measuring the vehicles themselves, the work that they were doing. And it was quite challenging. Some of the people there, maths wasn't their strongest topic and so on, and some of the ranges we had to do, whether the door was inboard or outboard, you'd have negative and positive numbers, working out ranges and things like that. And it was a bit of a challenge sometimes explaining to people how to fill out statistical process control charts. And I think, I don't know this for certain, but several people said to me that it was the first time that statistical process control was used on the production line, where the people did actually fill out the charts for themselves. So I really enjoyed doing that, and so that led on to other things, and I got involved with the area of the production line where the vehicles were checked at the end of the production line. So every day, it started off that we had 8, it later on moved that we only had 4, but we take 8 cars off the production line and they go for a road test. And they go into a booth where they're sprayed with water. We'd shake them around to make sure that they didn't rattle and so on. Full visual inspection over the outside, put little stickers onto them and so on to show anything. Then at midday, I'd be mic'd up with one of these sort of Britney Spears type mics, and I'd wander around the cars, and all the plant management would come down. And if there were any new issues there that we hadn't seen before, I'd point them out, and then that would be allocated to somebody to go away and sort it out. So that was enjoyable as well, but reactive, of course, because it was picking up things on the vehicles after they'd been made. So I was very keen to get into the more proactive side, and that came about because Ford had a system called Q1, Quality 1, I believe it stood for. And what it was something that they imposed upon their suppliers, where they go out and they audit their suppliers to make sure they were doing the right things in terms of quality. And then somebody quite sensibly had the idea that if we're expecting our suppliers to do this, why aren't we checking ourselves for it as well? So their plants started going through the same process as well. So they started doing internal audits. So I started being on the team that helped get their plants through this quality system. And then I heard about, and actually it was through my wife, because my wife also worked at Ford, and she'd been on a training course, and she said, "Oh, you've got to get yourself on this training course." She said, "It's absolutely fantastic." And it was called EQIP, the Engineering Quality Improvement Program. And I went on this training course, and it just knocked my socks off. It was fantastic. It covered a lot of the tools that people involved in reliability would get involved in, FMEA, so potential failure mode and effects analysis, design of experiments, quality function deployment, things like this. And it was presented really well. A lot of emphasis on really making sure that it was interesting to listen to and so on. And I went through this and absolutely loved it. And I got the opportunity to become one of the people who presented it. So one of the trainers, but it wasn't just about training. As well as doing the training, we'd also do internal consultancy in the workplace. So we go and help people to apply the tools. So by learning it well enough, you could train it. You had to know it really, really well, so you'd be good at delivering it. By delivering it, you'd have loads of examples. So when people would ask you questions about, what if you do this? What if you do that? You'd know because that had happened to you. Yeah. So I would say probably out of all the things that I've done in my career, that is the one that helped me the most. If you're going to present something like that, you've got to know it inside out and back to front. And it started at the end of the process with fixing things and resolution tools, things like that, and then it gradually worked upstream to how you try and avoid things in the first place. So I did that, and I've been doing it for a little while, and then all of a sudden there was a phrase that I kept hearing around the company. You know, when you have these big meetings that you go along to, and the top person's there talking about it, and it seemed like almost every other sentence had got this phrase in it: Six Sigma.
Yeah, Six Sigma. That's
what's this thing?
Back a bit for me. That what's Six Sigma?
What's this number and Greek letter that sounds quite complicated. Yeah. So I looked into it and I realised that it was these tools that I've been presenting and helping people with, but instead of being sort of shown as sort of standalone items, they were put together in a sequence to help you deliver improvement. Mm-hmm. So I thought, this is great, I want to get involved in this. So thankfully I managed to get onto the first wave of black belt training, so I could be one of the people who delivered this. Did that for a couple of years, delivered some successful projects, and then once I'd done that I was able to move on to become a master black belt. But within within Ford, they had this thing where you couldn't just carry on doing it. You could only do it for a set amount of time, for good reason, and that was they wanted to make sure they could get lots of people through the process, so lots of people could get understanding by becoming black belts, and then some of them moving on to become master black belts and so on. So I had to move on from it, and although it was great, I got involved in some good development work on some engines afterwards and so on. I really missed doing it. I absolutely loved doing that. And it was while I was sitting there regretting not being able to do it anymore that I got a phone call, and it seemed that Network Rail were looking for somebody to do Six Sigma on the railway.
Right.
This sounds interesting, doesn't it? And they wanted somebody who'd done it in various different parts of the business and so on. Yeah. And so I went along and they selected me. And if anyone's ever been involved in Six Sigma, it might not be any surprise it was the usual sorts of things that were the struggles here. They had 19 projects, and none of those projects had actually reached the improved phase yet. They were at the earlier phases. And one of the problems was that the projects were just scoped far too big. They had project titles like The Weather, Vegetation. They were absolutely huge. Yeah. So clearly, if you want to get some sort of movement with Six Sigma, you want some projects that are scoped down nice and small, so you can deliver one, get some benefits from it, use that to advertise how good it is, and then get some other projects going. So that was sort of half of the problem. The other problem was another thing you see with Six Sigma, where the people that were working on it were doing it part-time. They got day jobs. That was just getting in the way because they were fairly urgent day jobs. So trying to get on to do the sort of more proactive stuff they were trying to do with Six Sigma, it was getting in the way of that. So we needed some people who were doing it full time. So I was very fortunate that I got the opportunity to recruit a team of people to act as full-time black belts, which was fantastic.
Teams are always good, yes. So what are your primary responsibilities as a reliability engineer in the rail industry?
Right, so this is all connected to the design for reliability process. So initially it was creating the case for it and putting it in place. And it was something where I think ever since I've been working on the railway, I'd noticed I've been in a reliability team, and it was very much about reactive reliability, fixing stuff afterwards. And I felt that I really wanted to get involved in some more proactive reliability. And it was around about the time that we had a guy called Mark Kahn who became the Chief Executive Officer of Network Rail. And again, there was another one of these big all-hands meetings that everyone was going along to. And he said something very interesting. He'd just taken on the job and he said, bit daunting this, isn't it? I've just been made CEO. I've got to decide what I'm going to do to improve the company. Any of you got any ideas? And he actually said that. He said, if you've got any ideas of things that you think could be improved about the railway, don't keep them to yourself. Send them to me. Put them in an email, send them in. I thought, that's brave, isn't it? So I did that, and I wrote the email about, we need this process using some of these tools that are used in other industries and so on, and bring them onto the railway to, move a little bit more upstream, getting more proactive. And I sent this off. But it just got me reflecting and thinking, well, do you really need to be CEO to put this into place, or are there things that you can do yourself just to get it moving? And so I decided to do that. Right. And just before that, there was a guy there that worked, he ran the reactive reliability team, a guy called Barney Daly. And a little while before that, he'd given me a document that he'd got, printed off on an old dot matrix printer. I think it'd been photocopied 3 or 4 times. Yeah. And he said, do you think this needs updating? And I kept putting it off because it was really highly technical, the jargon in it and everything, and it was very thick. And I looked through this, and it was sort of where we needed to go. There were some relevant bits there, but there were some other bits that needed adding to it as well. So I started looking at that as well, and it appeared somebody had already had a go at trying to update it, and there was this other document that existed, but this other document also hadn't been mandated, it hadn't been formally released or anything like that. So I took those documents and my sort of background knowledge of the reliability tools and so on, and tried to craft what the design for reliability process would look like. Right. And of course, a lot of talking to the people from the reliability team to find out, what did they think were the big challenges that were getting in the way of us doing this. And also realising that whatever got put in place was going to have to work for so many different scenarios, because on the railway sometimes we just tweak things and we might maybe make a small change to it. Other times it's something that's really new, really innovative, something we've never ever done before. Or sometimes we get things where somebody moves their manufacturing process up the road, and because of that they have to get reapproval for it and so on. So a one-size-fits-all process was clearly going to be something that would waste people's time. And I didn't want to do that. I thought, in terms of selling this, it's really important that anything that we ask people to do has to add value. Yeah, otherwise people are not going to go with this. So it's all about making it scalable, deciding what the questions were that needed to be asked, and deciding what steps applied when. So making this scalable process. Then of course, that's almost like the easy bit. That might sound difficult.
How does that integrate with asset management? How does that integrate with it?
Well, this is the whole asset management process, because it's one of the issues that can happen with design for reliability is that people attempted to apply it too late. Some people were used to, we need to get product acceptance now to use something on the railway, we better pull the evidence together. But by that point, a lot of things have been fixed up in the design and are expensive to change, or really difficult and time consuming to change. So it's all about thinking about the overall asset management process. And at the very start, of course, you've got setting the requirements. And that's done by Network Rail as the customer, not by the suppliers. But if we don't do that right, we can't help the suppliers to do what they need to do about reliability right. So it's starting off with the requirements, it's then thinking about the risks in the design, but also thinking about the risks in the manufacturing process. But again, one of the things is, it's important not just to take a process that looks a bit like a process that's been used in the automotive world or the aerospace world and just saying, they do it that way, let's do it the same. You've got to customise it to make it efficient. So in terms of the overall asset management process, one of the things on the railway that we do a lot of that some of those other industries don't do is installing things. Yeah? Because a lot of our work is people fitting them onto the railway, and those teams are spread out an awful lot. You've got people down in Penzance, down in the southwest of the country, and you've got Wick in the north of Scotland. So there's lots of opportunity for people to install it subtly differently to each other. It's not like a factory where everyone's all in one place. They're dispersed. A lot of opportunity for variation. My background in Six Sigma taught me that that's all about avoiding variation, finding what's the best way of doing something, and then getting everybody doing it that same way. So we've got an extra phase within our process that maybe some other industries might not have, of thinking about the installation of it as well. So it's going through the whole sort of asset management process, although we don't really get to the disposal bit at the end for design for reliability, because by then it's served its purpose in terms of the reliability. Still something to think about, and it is sort of captured, because one of the things we have in there is thinking about whole life cost as well. Because it's not about just gold plating everything and having quality at whatever cost it is. Things are going to be value for money as well, because money has to come from the travelling public and the taxpayer and so on. So we need value for money. So it's thinking about the whole life cost, the cost of ownership, and of course the cost of disposal comes into that as well. So there are steps within the process where we think about that and about the cost of maintaining it as well. Because I've already mentioned about potential failure mode and effects analysis, where we think about the product and we think about what are the bits of the product, what are they there to do, how might they fail to do it, and then thinking about what the severity of that could be, how likely would it be, have we got any controls already on that? But sometimes you can't design things out, it's just impossible because it would be too expensive, or you'd be trying to break the rules of physics. So there might be some things where you have to manage
and maintain it.
Exactly. So what have we got left that's high risk, and with those high risk things, what maintenance strategies are we going to have for them? So it's the whole asset management process cuts across this.
All right. Can you explain the difference between preventative and predictive maintenance and how you can apply these strategies in this process?
Yeah, so that's pretty much that point, isn't it?
Yeah.
That the preventive bit is think about it as you're designing it, preferably before you've even started putting any pieces together, to create even a prototype part, and think about what can I do to avoid any failures in the future. Whereas the other bit is all about monitoring once it's actually operating, but also monitoring it, not waiting for it to fail and going to fix it, but monitoring some sort of parameter on it that gives us a clue as to when it's going to fail. And that's going to be really important, because clearly on a railway you only get access to go out there and do maintenance at certain times, because most of the time you want to be running trains. And because we want to operate in a safe manner, we do more and more work. We go out there at night now rather than during the daytime. And so therefore, if you want to try and go and do your maintenance at night rather than disturbing trains, you want to know what the status of your asset is, so you know how long you've got before it fails, so you can try and plan to go out there at the best time for you, not the best time for the asset, which isn't what you want, which is absolutely key to it. I mean, one of
the key challenges.
One of the key challenges there, of course.
You're on about it now. The challenges are not affecting the services during the day, and then.
Oh yeah, that's the challenge. But the other challenge with doing this is if anybody's looked at this and looked at these things where they call them P2F intervals, where you're looking at some parameter that tells you whether something's working okay or not. You start to see it change, telling you that it's in the process of failing. That's point P, when you can see it starting to change, and F is when it fails.
Right.
And we talk about those P2F intervals. How do you actually calculate them? Because the only way you actually calculate a P2F interval is by saying, oh yeah, it started failing, right, let's see how long it takes to fail, and leave it and wait for it to fail, which of course you don't want to do. And for me, that's one of the biggest challenges with those sorts of approaches, in terms of understanding how long something takes to fail. That can be one of the biggest challenges. But maybe if you can see the amount of degradation, you can sort of predict forward with it. But I think that's one of the biggest challenges with using those sorts of processes.
I think it's the same for everywhere. The biggest challenge is that period of time and getting that failure distribution accurate. Because if you know what the time of failure is on some items, then you'll be able to calculate a failure distribution. But is that failure distribution representative of what you're looking at?
Yes.
It's just like, is it still a finger in the wind situation? They say, well, I've got a tiny bit of data, it might be right. It's a good prediction. I've stopped something going wrong, but did I?
And that tiny bit of data is key as well, isn't it? Because if you haven't got a large sample size, you only know about a few of them. One of the problems there is that of course that time to failure has got to be consistent as well. So it's no good if sometimes you get an indication that it's changing and it's going to be a year before it fails, and another time it's only going to be a day before it fails. And with small sample sizes, you might not know whether it's going to vary greatly. So it does need to be consistent.
Okay. How has technology impacted the work in reliability engineering, and can you describe any specific processes or standards you would require in asset management?
I guess in terms of technology affecting reliability, one of the things is that there's a lot more tools out there for crunching large amounts of data. Because the trouble is, it seems It seems that one of the issues that we get with data is we either have too little or too much of it. You either haven't got any, or there's so much of it that you've got to get behind it.
Yeah.
And one of the things that has been said before, and it was that same CEO that I mentioned earlier, Mark Kahn, that mentioned that when he came in, he said that he believed that there was potentially more sensors on an aircraft than we had on the railway at that time. And back then he might have been, yeah, and back then he may well have been right, but boy, has that changed since. Yeah, with the people that from him and the people that have come in afterwards, putting things on to monitor the railway, we have so much data coming in now that the key issue that we have is how do we get behind that? How do we work out what's important, what's not important? That's the key issue we have with that. I guess in terms of other technologies as well, I guess we've got things like the ways that we go about inspecting things. So these days, drones. Don't think when I started with the company, drones were really a thing at all. Yeah. So drones for inspecting the railway, those sorts of technologies, and possibly linked up with the likes of AI and so on. Yeah. I think one of the limitations, I don't know, I think it's still there at the moment, that they have to be used with line of sight. Whereas if that can change in the future,
I
that
believe
can
that might be changing. So yeah, there's mention on any particular standards that you have to adhere to, or
well, NR L2 RSE 0005. That's the top. That's our design for reliability standard. Top plug there for the design for reliability standard. I mean, there are other standards as well that we had that existed before design.
You didn't write that one by any chance?
You
might have done.
Nobody writes a standard in isolation though, do they? And there's been a lot of input. We're on the 5th version now, because if any of you have ever written a standard, you probably know how much work goes into having work groups and listening to stakeholders and getting their feedback to update it. But even though you go through all that, you answer all these questions, you update it and you improve it, it's not until you really put it out there in the real world and you get feedback from it that you really learn how you can improve it further. So people who've used the standard, people who come through the training, giving feedback on the standard, which means that we're now on version 5 of that particular standard. But prior to it, we did have some other standards, but they were very high level. And occasionally people have said, oh, we follow this other high level reliability standard for the railway. Does that mean we don't need to do design for reliability? But the trouble is, those high level standards, they told you what you need to do, but they didn't really tell you how you need to do it. Yeah. So there was lots of variation in terms of how people approached it. Some people doing bits of it well, some people not doing it so well. And of course, if people do it in very different ways, it's not really auditable. So how do you check that it's really being done?
Difficult to audit when it's not. Well, it's going back to Six Sigma again, isn't it? You know, it's doing it the same way.
Yes.
So yeah. How do you assess and manage risk associated with rail asset maintenance?
Yeah, so again, this is this bit where we do the FMEA first of all to try and design things out, and this is the bit where we look at, can't design it out, what are we going to use for maintaining it out? And some people may be familiar with the term FMEA instead of FMEA. And sometimes this could, in terms of terminology, this can be a bit difficult, because sometimes people just use the terms interchangeably. And I've seen an FMEA labelled as a FMEA labels an FMEA. I've seen all these different combinations. But the difference really is that the FMEA, as we define it within the DFR standard, is that the FMEA is the avoidance bit, and the FMEA is looking at those remaining bits, looking at how we go about maintaining things, how we know something is in that process of failing and so on. But we've avoided using the term FMEA in there. And we've used other words to describe what we do, because we don't want to confuse people, because of that fact that people use FMEA and FMEA to use different things. And this is one of the things that you have to do, isn't it? When you're working with lots of different suppliers who might have been using these with different industries that they deal with, you want to make sure that there's no confusion there, where there might be some ambiguity over terminology. Yeah,
because you've got the... So FMEA, for anybody catching up on the terms, failure modes and effects analysis, and FMEA, failure modes and criticality analysis.
Yes. I always put the word potential there when I talk about FMEA, even though it's not there. I always call it potential FMEA, because people worry about putting things on there, don't they?
As a high level, it's added criticality, and when you go back to MIL Standards 1629, criticality is a completely different thing to other standards who talk about criticality. So the term FMEA is quite loose,
Yeah.
So what measures do you take to ensure safety and reliability in the rail operation?
Yeah, well, this is one of the things where I've got a point of view on this.
Oh,
that
right,
we
okay.
a lot of the time we do tend to keep differentiating between safety and reliability. Yeah. But the point that I've been stressing to a lot of people recently is that the sorts of tools that you use to make something safe and make something reliable are the same. Yeah? The analysis is the same. The only real difference between reliability and safety is the consequences. Yeah, because some of the things that fail on the railway will delay trains, but some things, if they were to go wrong, they could harm somebody, so they could lead to a safety type incident. So it's the consequences. If you make something reliable so it can't fail in the first place, it's not going to fail in a safe way, but it's also not going to fail in an unsafe way as well. But also there's the other element of safety in this as well, that if things don't fail, regardless of whether they fail in a safe or unsafe way, you don't have to send somebody onto the railway to go and repair them during the daytime, so you're not exposing somebody to a railway environment. Not just thinking about going into a railway environment where you might have trains, but also, opportunities for slips, trips, falls, things like that as well. So a reliable railway is a safe railway, which is one of the things of our new CEO, Jeremy Westlake. That was something that very quote was something that he said in one of his most recent videos that he put out there.
Can you share a specific example of successful reliability improvement projects you have managed?
Yes, well, I'll go for a railway one because it's very significant to the design for reliability work. And that was before putting design for reliability into place. I got involved in a project looking at railway relays, so switches that we use in electrical circuits on the railway. And we've got about 1.5 million of these on the railway. This is key, because if you've got something you've got lots of, even if it's not your least reliable thing, even if it's sort of halfway down the list, you've got a lot of opportunity for making a difference if you can make it more reliable. Your most unreliable thing on the railway, you might only have 2 of them. So if you do make that more reliable, the amount of effect you have in terms of making the railway available to run trains on it isn't as large. So the quantity, how many you have of something, can be just as important as how reliable it is. Yeah. So, and sometimes people have said to me, if you went back and did DFR again, is there anything you'd do differently? I wouldn't call it design for reliability. I call it design for availability, because availability is what's important. That's what somebody who's travelling on the railway wants. They want to get from A to B safely in the time that they expect to. And if you've got something... Yes, and if you've got a product that maybe you've got redundancy in there, so that you've got 2 parts to it, one of the parts fails, the other one kicks in, might not be very reliable, but if you've designed it well and you can get in there and sort that first one out before the second one goes wrong, you're keeping things running.
Or
so you're
the second
keeping
one
it
takes
level.
over automatically.
Yeah.
Fix it later. Just kind of one fails and redundancy jumps in. So
and also, if you've got 2 products and one of them is, it's got a reliability where the mean time between failure is, say, 150 years, and the other one was 100 years, you might immediately look at it and say, oh, I want the one where the mean time between failure is 150 years. But maybe this one always fails at the same time, whereas this one varies greatly when it fails. So if you know when something's going to fail, so you can go in and you can work on it and you can fix it before it fails, that's more important.
So what are some current trends in rail asset management that you find exciting or promising?
Oh, well, there's got to be one at the top of the list here, isn't there? It's in the news at the moment, the move to Great British Railways and the opportunity for closer working between train and track. I mean, the opportunities that gives in terms of being able to put things on trains for monitoring the infrastructure and thinking about things much more joined up as a system is absolutely fantastic. So that's one of them. The other one is in-cab signalling. So rather than controlling the railway by having signalling at the side of the tracks, posts with a light on the top of it, by having it controlled inside the trains, it does give the opportunity there for making the sections that the trains operate in smaller. And therefore running a large number of trains safely on the railway, So if you can run more trains, then the timetable can mean that people can get where they want to go faster and have trains at other times of the day and so on. So that gives lots of opportunity as well for that.
Increasing connection opportunities.
Yes,
Yeah.
but of course it gives a risk as well, because first of all a risk in transition, because if during the transition, if there's any time when we have both systems at the same time, so if we have some trains that had that and some trains that relied on the signals at the side of the track, whenever you had two systems working at the same time, of course, the system can never be more reliable than the least reliable of the two, yeah? And,
Right.
you know, either, you know, even if the second system's really, really reliable, yeah, this one could fail or that one could fail. And if you've got a train that's using the lights on the sticks behind a train that's using the other system, and one fails and the other one fails, doesn't matter if the other system's still working, they can't get where they're going.
Right.
So that's something I think that needs to be recognised, and people need to think, you know, you've got to wait until it moves to the new system before you can
Right.
fully assess it. If anybody looked at it and said, oh, hang on a minute, it's taken a bit of a downturn, that would be an unfair assessment. Yeah. If it's just switched overnight and you go from one system to the other, that's another story. But if you've got that, that's a little bit different.
Okay.
But also, if you're running more trains, then of course, if you do get some issue with the railway and a train breaks down, you're going to get more consequential delay there, because you're going to get more trains behind it that get delayed. So if we do this, yeah, there's the opportunity for a much better service on the railway, but it makes it even more important that we've got a reliable railway.
How do you stay up to date with the latest advancements and best practices in the rail industry?
This sounds like an opportunity for plugging the IMechE, I think, here, because I go to a lot of
Why the
IMechE
IMechE,
conferences.
Kevin? Why the IMechE? What's your significance for the IMechE?
Oh right, yeah. So I'm chair of the IMechE's Work Group 1 within the Safety and Reliability Group. And Work Group 1 is specifically engineering for reliability. But of course, as I said before, if it's reliable, then it tends to be safe as well. And every year we run a conference, and it's been very successful in the past, to the extent that now it's a 2-day conference rather than a 1-day conference.
It is. That's how we met, by the way. That's how I know him.
And over the past few years, we've run this in Manchester, and it's going to be Manchester again in the coming year, next year. I think it's April sometime that we've got the date in the calendar for that. And yeah, it's fantastic listening to the people that we get come along. We've always had some really interesting speakers come along, and I always learn an awful lot from that. So that's great for learning. But also, actually, within the work group itself, one of the things we've done, we've just kicked off a sub-work group. Which again you know about, being part
Yes.
of it, and this is looking at not just the reliability of products, and you'd have thought with the IMechE there's a focus on physical products, but one of the things that sometimes as mechanical engineers we don't know as much about is reliability of software that might be embedded in products. And at the moment, our design for reliability process we have looks at physical products, but it doesn't add anything above and beyond what we've done with software in the past. So it's not a backward step, but it doesn't add anything new. And one of the reasons is with mechanical products, there's lots of tried and tested methods out there, but with software, there's lots of different approaches people take to making software reliable.
Kevin, thank you for coming. So it's been an absolute pleasure having you here on the ReliaCast channel. And yeah, guys, like and share, the usual jargon down below. And yeah, we'll catch up with you with the next video in the new year. So thanks for watching. You've been watching ReliaCast. I'm your host, Chris Wynn-Jones, and my guest, Kevin Raymond. Thank you very much.